All right, welcome to This Explainer. Today, we're going on a seriously mind-bending journey. We're going to look way up at the vast, seemingly infinite universe, and then, well, look right back down at the four walls around you. And we're going to do it through the exact same scientific lens. We're talking about habitability. Now, you hear this word thrown around in sci-fi all the time, but the actual science behind it, it totally bridges the gap between deep space exploration and the literal room you're sitting in right now. So before we blast off into the cosmos, I want you to take a quick look around. Really look at the room you're in. What actually makes this place feel like home? Or, at least a place where you can hang out comfortably for a few hours. Is it the temperature, the air you're breathing, maybe the natural light coming through the window? Hold on to those specific comforts, because that basic everyday intuition about what makes a space comfortable, that's going to set up a massive macro to micro scale jump we're about to take. Okay, let's get down to brass tacks. At its core, habitability is simply the measure of whether an environment can support life. And notice how incredibly broad that is. This one single term applies just as perfectly to a planet light years away as it does to a natural ecosystem like a coral reef or even a man-made structure like an office building. It's the ultimate unifying metric for both astrobiology, looking for life out there, and environmental science right here on Earth. It's the ultimate test of survival. Section 1. The Planetary Goldilocks Zone. Let's zoom all the way out to the macro scale and see how astronomers actually figure out if a planet can sustain life long term. They use the Circumstellar Habitable Zone, or CHZ, which you probably know as the Goldilocks Zone. For a planet to be viable over a massive stretch of time, its distance from its host star has to be absolutely spot on. Not too hot, not too cold. It needs a surface temperature that lets liquid water actually pool, rather than just boiling off into space or freezing solid. But being the right distance from a star is really just step one. The ultimate cosmic recipe for life needs a few more absolutely critical ingredients. First, you need that liquid water acting as a biochemical solvent. Then, you need an energy source. Could be stellar radiation like sunlight, or even chemical energy like geothermal heat bubbling up from the core. Third up is atmospheric stability. You need an atmosphere thick enough to maintain pressure and actually shield the surface from harmful space radiation. And finally, you gotta have the right chemical building blocks. And scientists actually have this brilliant little acronym to help us remember what those building blocks are. CHNOPS. That stands for carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. If you've got a planet with a stable atmosphere, a solid energy source, liquid water, and these specific elements, well, congratulations. You've got a planetary environment with the fundamental, super exciting potential to actually support life. Now here's where it gets really interesting. When we look out at the stars, planetary habitability is pretty much a binary question, right? Like, can a species physically survive, yes or no? But bring that exact same lens back down to Earth, straight into your living room, and the math changes completely. Urban habitability isn't about avoiding the freezing vacuum of deep space, it's about thriving. We aren't just trying to survive the day, we're trying to absolutely optimize the quality of our living conditions. Section 2. Designing Human Habitats. Bringing our focus completely down to the human scale, architects and urban planners govern our living conditions using three main pillars. To make any building or city area truly habitable, they have to optimize the indoor environmental quality, ensure rigorous safety and sanitation, and, crucially, foster psychological well-being. Without all three of these pillars working together in perfect harmony, our man-made environments basically start failing the habitability test, and our quality of life completely tanks. Let's look at that first one. Indoor environmental quality, or IEQ, builds perfectly on that Goldilocks metaphor we talked about earlier. Just like a planet needs to be the precise right distance from a star, we need an indoor climate that is perfectly regulated. IEQ means thermal comfort. Not too hot, not too cold inside your house. It means air quality, making sure we're breathing clean air and not a bunch of toxins. And, fascinatingly, it includes acoustics. Literally, the noise levels around you deeply impact whether a space is actually a comfortable place to live and work. But hey, it goes way deeper than just a quiet room at the right temperature. That second pillar, safety and sanitation, means access to clean water, reliable waste management, and the literal structural integrity of the building so the roof doesn't cave in on you. And then there's the third pillar, psychological well-being. This is where habitability gets deeply personal. To be psychologically healthy, we need natural light. We crave privacy to decompress, but at the same time, we need social spaces to connect with other people. Think about your own home again for a second. It's the balance of these exact elements that dictates your everyday mental well-being. Section 3. The Drake Equation. Okay, we've looked at the galaxy and we've looked at our living rooms. Now we're going to fuse the macro and the micro right together. When astrobiologists estimate our odds of finding neighbors out there in the dark, they don't just guess. They use the Drake equation. It is this incredibly ambitious tool designed to estimate N, which is the number of habitable intelligent civilizations in our galaxy that we might actually be able to communicate with. It essentially takes all those conditions for life and scales them across the entire Milky Way. Honestly, think of this equation like a massive cosmic filter. We start big. What's the average rate of star formation in our galaxy? Then the filters start to narrow. How many of those stars actually have planets? Of those, how many sit right in that cozy Goldilocks zone? But as we know, potential isn't reality. So we filter again for planets where life actually manages to emerge. Then we filter for intelligent life. Finally, we filter for civilizations that develop detectable technology and factor in just how long they can blast those signals into space before fading away. You multiply all those shrinking probabilities together, and boom, you get our odds. So what does this all mean when we bring it together? We've mapped out the cosmic recipe of water, energy, and CHNOPS. We've seen how human architects painstakingly recreate those perfectly balanced conditions inside the concrete and steel of our cities through thermal comfort, light, and social spaces. And we've just looked at the sheer statistical weight of the Drake equation, filtering billions of stars down to the slimmest chances of finding another technological civilization. So look around your comfortable room one last time. Think about the math of the cosmos and ask yourself this. Given the incredibly delicate, miraculous balance required to create a truly habitable space, whether that's an entire planet or just a quiet, sunlit room, are we a massive statistical anomaly, entirely alone in this vast universe? Or is our galaxy actually teeming with other civilizations carefully constructing their very own comfortable homes right now?